In-class activity 12E, strategies for factoring polynomials. 1. Have you ever figured out how something was made by taking it apart? Give an example. Perhaps you learned how to repair bikes by taking them apart or disassembling different components of your bike and then putting them back together. So that would be one example. Objectives for the activity. You will understand how to develop strategies for reversing a mathematical construction, that a polynomial function can be written in both standard form and factored form. You will be able to find factors of a polynomial, convert a polynomial from standard form to factored form. Scientists and engineers often use reverse engineering techniques to learn about the structure of objects. Reverse engineering usually involves taking something apart, examining the pieces, and thinking about the process by which it was made. In mathematics, we can reverse engineer certain formulas to learn something about the functions they represent. 2. In class activity 12D, you found a function for the volume of a box formed by cutting squares out of the corners of a rectangular sheet of paper and folding up the sides. The only quantities given in this problem were the dimensions, length and width, of the sheet of paper. You use these dimensions to find a formula in factored form, which could be converted to standard form. Let's scroll up to the next page. And there we go. Suppose that your friend did a practice problem of this type and arrived at the following formula. In standard form, a of x is equal to 4x cubed minus 22x squared plus 30x. Assuming that your friend did the problem correctly, what were the given dimensions of the sheet of paper? So to work this, let's see, let's notice that, I'm just going to copy the function down again, 4x cubed minus 22x squared plus 30x. If you think back, the problems that we worked with, they all started with an x. That was what we cut out of the corner of that box, or the height of the box that it eventually ended up being. So each term in a of x has an x. So let's factor out an x from each term, and we're left inside the parentheses with a 4x squared minus 22x and then plus 30. At this point, notice that, let's see, what do we have? We have an x, and if we were to factor, remember what these problems looked like? It was always a minus a 2x and a minus a 2x, and then it was the width times the length. That's what they ended up looking like. So working toward that end, well, I'm out of room here. I'm going to go back to the top of the page here and start writing. So we have an x, and then the width times the length. I need a 30. So why don't we look at the factors of 30? We have 1 times 30, we have 2 times 15, we have 3 times 10, and we have 5 times 6. So what I'm going to do, put an intermediate step in here, and I'm going to write the 30 first, and then the minus 22x second, and then plus 4x squared. Now we have an x here. That's going to allow us to write minus 2x, a minus a 2x, and then the factors of 30 that multiply together to give us 30, but also give us the number 22 when we add them together. You're going to, after some experimentation, you're going to find out that 5 and 6 is the only combination of numbers that work. So the width we're going to call 5, and 6 is the length. So we can say that the width is 5 units wide, and the length is 6 units long. Now, part 3. If we reflect on our strategy for answering the previous question, question 2, List the steps that we use to reverse engineer the problem. Well, something that we could do, we first noticed that we had to have this form, x, and then just copying what we have above here. We factored out an x. And then once we did that, we noticed that the problems always ended up looking like the width minus 2x times the length minus 2x. So then we went to the top of the page, and what we did was we switched the order around. We wrote the 31st, kept the negative 22x in the center, and then plus 4x squared. And then we went back and filled in the rest of the problem. So with the proper numbers, we had a 5 minus 2x, and then a 6 minus 2x, not a 6 minus 6x. There we go. Part 4. Factor the polynomial x cubed minus 4x squared minus 12x. So let's do this. If we factor out, it says first factor an x out of each term. So we'll get x, and then we'll get x squared minus 4x minus 12. The remaining factor should be quadratic, which it is inside the parentheses there. Your final answer should have 3 linear factors. So I'm just going to work over here. We have the x to start with. I have x times x gives us x squared. And now if I look at the factors of 12, we have 1 and 12, we have 2 and 6, and then we have 3 and 4. Now, I know all of these numbers, 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. So that's only one of the things we need to happen. We also need to add these together to get a 4 or a negative 4x. We can see that the only two numbers that have a difference of 4 would be 2 and 6. So why don't we take x, let's see, we need a plus and we need a minus. So it's going to be an x plus a 2 minus a 6. So x plus 2, x minus 6. And there are our 3 linear factors. Part 5. The polynomial x cubed minus 6x squared minus 38x plus 8 is the product of a linear factor and a quadratic factor. Part A. Jessica graphs the function f of x equals x cubed minus 6x squared minus 38x plus 8 using her graphing calculator and notices that x equals negative 4 is a root of this function. She realizes that this gives her the linear factor. What linear factor did she find? Well, if the root was x equals negative 4, the linear factor is going to be x plus 4. We can even write it in parentheses there. Part B. Kenny observes that the quadratic factor must have the form ax squared plus bx plus c, where a, b, and c are numbers. So he writes x cubed equals 6x squared minus 38x plus 8 equals Jessica's linear factor. I'm going to write that in here. Jessica's linear factor we just found to be x plus 4. And then we have ax squared plus bx plus c. I'm going to scroll up here, and it says find a, b, and c, then write the polynomial as the product of a linear factor and a quadratic factor. All right, so we have the factor x plus 4, and then we have the quadratic factor ax squared plus bx plus c. So why don't we, I'm just going to write this on the side here. We have an x and a 4, and then I have ax squared plus bx plus c. Multiplying I'm sorry, multiplying x times ax squared, we get ax cubed. And then multiplying bx times x, we get bx squared. And then c times x is cx. Multiplying the next row, let's see, we get 4ax squared, and then 4bx, and then 4c. Knowing that on our diagonals here, we have the common factors of both of those are quadratic factors. Let's write this out here to be 4ax squared plus bx squared. And I'm just going to rearrange this a little bit, factoring out the x squared common. So we have 4a plus b times x squared. Well, this piece here, that's our coefficient of the quadratic term. So if I go back up to here, it has to be -6. So what I'm going to do is write 4a plus b equals -6. Now we have a single equation with two unknowns, but notice the quadratic factor, or the cubic factor here, is a 1. So it's 1x cubed. So I know the a has to be a 1. So this reduces to 4 plus b equals -6. If we solve this for b, I'm just going to go back up here to save some room. B is going to be equal to -10. So far, we know a, so a is 1, b is -10, and it remains to find c. So c is going to be equal to something to be determined now. Going back to our box here, I'm looking on the diagonal where the linear factors are, and then I'm going to come down here and just squeeze this in here. We have 4bx plus cx. Factoring out the x common, we're going to have 4b plus c times x. And again, this piece right here, the 4b plus c, that has to be our linear factor, which we see here as negative, or linear coefficient, which is a -38. Let me write that so you can see the -38 better. There you go. So if I just write that here, we have 4b plus c is -38. We found b. B is -10. So this really is 4 times -10 plus c is equal to -38. Saving room, I'll just go up here and write it to the right. We're going to get -40 plus c is -38. So c has to be 2. There we go. Okay. And let me just, it's getting kind of crowded here. Let me write this down. I'm just going to write it in the center here. I'm going to put a box around it. Because part B says write the polynomial as the product of a linear factor and a quadratic factor. So the linear factor, we found that was x plus 4. And then the quadratic factor, a is 1. So that would be 1x squared, or just simply x squared. B is -10x. And then the c, the coefficient c is 2. So it's going to be plus 2. So there we go. Then we have a linear factor times our quadratic factor. Part C, down here now. Should Kenny keep trying to factor, or is he done? And how do you know? Well, Kenny is done. And we know Kenny's done because if we look at gosh, it's getting so crowded. Let me just highlight this in a different color. If we look at what I'm outlining in this different color, this pink color, it's a trinomial, x squared minus 10x plus 2. And then if we think about factoring this, the factors of 2 are 1 and 2. So 1 times 2 is 2, but 1 plus 2 is equal to 3. And we need it to be equal to -10, which it's not. So knowing this, then that tells us that we are done factoring this. Let me go back to writing in blue. Now, part 6, write the polynomial x cubed plus 4x squared minus 11x minus 30 in factored form. So it's getting so crowded here. Let me just restate that part. Whoops, there we go. I don't know what happened. Write the polynomial x cubed plus 4x squared minus 11x minus 30 in factored form. Let me erase that line. So let's do the same thing. I'm going to factor out here. Now let's do this. Let's graph. If we graph this, let me tell you this. We graph it, suppose we graph it, and we see, let's see a root of x equals -2. So that's going to lead us to a linear factor, x plus 2. This is how the other example started. So suppose we graph this, we got, a root -2. That tells us that we have a linear factor x plus 2. So let's start there. So we could write, remember we could write the linear, I'm just going to go down here and write where number 7 is. Linear factor times our ax squared plus bx plus c, our quadratic factor. So we're going to have x plus 2 and times ax squared plus bx plus c. So let's do that, make that box again. We have an x and a 2. We have an ax squared. We have a bx and a c. We draw our box. Once we draw the box, we'll start multiplying. So we get ax cubed, and then we get bx squared, cx, 2ax squared, 2bx, and 2c. So let's look on the diagonals again. So that diagonal that I just highlighted with this box will give us the quadratic, or highlighted the quadratic terms. So we have 2ax squared plus bx squared. Let's factor out the common x squared. So we get 2a plus b times x squared. Notice again, what is a? I'm going to go back up to 6 here and draw an arrow over this. That term has a coefficient of 1. The cubic term has a coefficient of 1. So we know that a is equal to 1. So this here is just telling us that 2 plus b x squared. So 2 plus b is 2 plus b is the coefficient for the quadratic term, which is just a positive 4. So we're going to get 2 plus b is equal to 4. So that tells us that b is equal to 2. Let's do this again. I'm going to go on the diagonal, just drawing a box around it. So this diagonal that I'm drawing is telling us that 2bx plus cx, that's the linear information. So we're going to factor out the common x from both terms, and we get 2b plus c times the x there. b we just found to be 2. So that's 2. So we're going to end up 2 times 2 is 4 plus c. This is the coefficient for the linear term. Looking up to number 6, the linear term, I'm highlighting now, just drawing a circle around the -11. So let's do the same thing. We have 4 plus c is equal to -11. So c ends up being equal to -15. Okay. Okay, now taking this information, and we also know that the a was 1. I'm going to go up here, and we write x plus 2. There's our linear factor, times a, which is 1, so we get times x squared, and then b is 2, plus 2x, plus, a -15. I'll just write it as -15. Oops. -15. And let's do this. I'm going to erase that arrow and I want to work up in the same part of the screen here. And I'm looking at 15 here, negative 15. Factors of 15, we have 1 and 15. We have 3 times 5. 1 times 15 is 15, obviously. 3 times 5 is 15, obviously. But I'm looking for any combination of the 1 and the 15 or the 3 and the 5 that also, if I add them together, have a difference of 2. And it looks like the 3 and the 5 could work. So we could continue to factor. Let's just test this out. X times X gives us X squared. And then a 15 is a 3 and a 5. And we need a plus 5 and a minus 3. So we get X plus 2, X minus 3, and X plus 5. And that is the factored form. Let me just highlight that there. Now that was all number 6, and we took a lot of room to write that. And going on to number 7, so here we are at number 7, it says summarize any patterns or strategies you have found useful for finding the factors of a polynomial function. Okay, so let me just write number 7 here. So if there's anything we can write here, say it'd be to factor a polynomial function. We first identified a linear factor, and identify linear factor. And we can graph this. So I want to put technology here. That's how we first started out here, graphing it, and noticing a 0 or roots of the polynomial. And we can use technology to do that. And then if the function has roots, then what we did was we identified their corresponding linear factors. So the linear factor, comes from the root that we found. And then once we have identified the linear factors, we tried rewriting the polynomial function. For example, if the polynomial function was cubic, like the examples that we did here, what we did was we wrote it as a linear factor times the quadratic factor, which we wrote as ax squared plus bx plus c. And once we had this, at this point, we would make a 2x3 table. And start looking at the patterns. Okay, start. And that's when we drew the diagonal boxes around or the rectangular boxes along the diagonals to identify first the quadratic terms and then the linear terms and so forth. And the diagonals of the table, they contain like terms, which we just said, and we use these terms to identify or solve for A, B, and C. That is the end of this video. Thank you.